ವಾಯ್ಸ್ ಕ್ಲಿಯರ್? ವಾಯ್ಸ್ ಕ್ಲಿಯರ್ ಆಗಿದೆಯಾ? ಡಿಸ್ಪ್ಲೇ, ವಾಯ್ಸ್, ಎವ್ರಿಥಿಂಗ್ ಓಕೆ? ಓಕೆ, ಸ್ಟಾರ್ಟ್ now. See, actually it started raining now. No rain up to 7:30. When I started, correctly rain was waiting. Okay, right now no problem. If it rains very heavily, if I can't hear my own voice, I will not stop the streaming, because what happens is, if I stop it, I can't restart. I have to learn that one. So I will just wait. The question yesterday, make a note. You should make a note here. See, the given question yesterday is there. Draw a neat sketch. You write here first, alternate solution. Alternate solution, that is practically more important. The more important is practical knowledge, or you can write correct understanding for cantilever. You again make a note. See, when you want draw SFD&BMD, traditionally what you do is, you start from left side, then go there. See, one very important note, you should write right now only. See, when our sign convention for shear force is left is up, right is down. Therefore, if you start from left side, suppose you come this way. As you come this way, any upward positive, any downward negative. So, if it is upward, you go above the baseline. Downward, you come below the baseline. Or you can write one thing, you go with the load. See here, go up by load, come down by UDL, come down by 60, come down by UDL, come down by 40, come down by that UDL, come down by 30. So if you start left to right side, you go with the load. Simple to understand. Go with the load. Load is going up, you go up. Load is coming down, you come down. So easy to understand. But if you start from right side by chance, see, right side is what positive? Tell me. When you find SF, this is positive. Left side is upward positive. Right side is what? From right side, which is positive? See, when left up is positive, automatically for positive, right what? From right side. For left up, automatically along, see, by language only can make out. Left up positive means right what positive? From right side, which positive? First of all, I should not tell this one. It is 1,000 times over. If you look right side, which is positive? Answer illa. If you see right side, which is positive. Sign convention is there here. Downward positive. So, if you start from right side, make a note. Downward positive. So, usually positive, you write above the baseline. Negative, you write below the baseline. So, if you start from right side, the problem is that if the load is coming down, it is positive shear. So, you have to mark upper side, positive. If the load is going up, you have to mark what? It is negative. So, you have to mark down. Or, remember, if you start from right side, you have to go with the load or against the load. If you start from right side, you have to go with the load or against the load. Against means what? Load going up means you come down. Load coming down means you go up. What do you have to do? You have to go with the load or against the load. With the load. It is waste time. This much time I told is wasted. With the load. If you go with the load, what will happen? Right side down, you will come down. When you come down, you come below the baseline. You go against the load. Just a minute. See here. For simple example, see here. You take a simply supported beam. Take 2-point load, just to understand. 60 kilonewton and 50 kilonewton. Reactions, just randomly, ದೂರ ಹತ್ತು ಒಂದು 55 65 kilonewton and 45 kilonewton randomly placed. This load is very near. See, shear force diagram. If you start from left side, left up is positive. So, if you plot the shear force diagram from left side, you go with the load. See here, go up by 45. No load up to here. Okay. Come down by 60. That is 15. No load up to here. Go this way. Come down by 50. How much? 65. No load. Go up by 65. Plus, minus. Clear? Fast. This is the shearing force diagram. If you start from left side. Clear now? That's how you draw shear force diagram. Clear or not? It is clear on Taila. This is what you are doing earlier. Clear. Okay. Now, suppose you start, it came back. Suppose I should have put inverter on. Next time if required, I will put inverter on. If rains, if it starts lightning, they remove the power. Okay. Now, if you start from right side, see now, what happens? Shear force diagram should come same. It can't change. If I will remove now, if you start from right side, if you see, left up is positive, right down is positive. Illi right 65 up. So 65 up from that side if you come is positive or negative. If you look that side, see, right side 65 up. So our sign convention, left up, right down positive means the 65 is positive or negative. First, 65 is positive or negative. If you stand here and look that side, 65, ಪಾಸಿಟಿವ್ ಆರ್ ನೆಗೆಟಿವ್? ಇಷ್ಟೊಂದು ಕಷ್ಟನಾ? Then what about 100, class number 114? That's 65. If I stand here and look that side, right side, left up, right down, positive. That 65 is positive or negative? This much difficulty I have never seen. That is basic sign convention only not clear. It is negative. So what happens? You should plot 65 down, but load is going up. So what you have to do is, if you start from right side, you should not go with the load. You should go against the load. Nodi, illi. Load goes up by 65. Okay. No load up to here. Then load comes down by 50. You go up by 50. Still 15 remains. No load. Comes down, you go up by 60. This will be 40. No load up to here. Here, up 45. 45. Are same. Diagrams are same. Clear now? So remember, if you take left up, right down, positive, so you make a note. If you take as per our universal convention of left up, right down, positive, for shear force diagram, if you start from left side, you go with the load. If you start from right side, you go against the load. People want to avoid it. Going against the load, what will happen is, they will do correctly. After some time, suddenly mistake. Load coming down, they will come down. Gone. So if you start from right side, why? Common sense. Right side, down is positive. So down means you have to go up. Up means you have to go down. Clear now? So if you start from right to left, if you start from right side, come towards left side, and if you go with the load, if you are covering the load, everywhere you have to go what? Against the load. Load going up, you come down. Load coming down, you go up. Clear? Fast. Make this note. This is only for shear force. Clear or not? Okay. Now make a note. Anyway, practical point of view, suppose you start from right side, come left side with the load. Suppose you start this way. See, practical point of view. Suppose you start from right side, you come with the load. Go up by 65. No load. Come down by 50. 15. No load. Come down by 60. 45. Go up. Then sign will change. You can imagine left down positive, right up positive. Practically design purpose, nobody wants sign for shear force. Therefore, numerical value will not change. First of all, when you go to practical design, we want only shear force. What do you require? Shear force here, 45. Shear force here, 65. Nobody will ask you plus 45, minus 45, etc. So, that is practical point of view. But correct point of view, remember. Now, this is fully clear, I think. It should be clear. Okay, now, go further. Now, as I told last time, for a cantilever beam, when you draw SFD&BMD, yesterday I have given an example for you. See, tell me, shear force will keep on increasing under normal loading cases. Bending moment also keeps on increasing if you start from which end? See, I already told you, suppose there is a cantilever fixed here and free here, or a cantilever here, fixed here, free here. Any normal loading, not special loads all. See, don't tell upward load, couples all, leave it now. See, now, here no shear force, unless there is a point load. As you come here, when you come here, this much force will create shear. When you come here, this much force will create shear. When you reach here, entire force will create shear. When you reach here, this much moment will create bending moment. When you come here, this much load will create bending moment. When you reach here, entire load will create bending moment. So both shear force and bending moment, when you start from free end, when you go to fixed end, it keeps on what? Tell me. Not like simple support beam. Simple support beam, support maximum, then what? It becomes somewhere 0, then changes. Bending moment, support 0. 1, if from support if you start up to somewhere increases, then again decreases. No, in cantilever, if you start from free end and go towards fixed end, shear force, bending moment, both will what? Shear force and bending moment, both will keep on increasing. And one more thing, it is the correct concept. See here also. If it is cantilever here, if a point load is there, shear force is there, or no shear force. When you come here, start here, this much force will create shearing force. When you reach here, this much force will create shear force, more shear force. When you reach here, entire force will create shearing force. And here, only moment of this much load. Here, moment of this much load. Here, moment of full load. So whether it is fixed at left end or fixed at right end, if you start from free end and go to fixed end, it gives the correct idea of SF and BM variation. Now, suppose there is a reaction here and a couple here. If you find bending moment here, looking this side, this reaction into something will give positive. Positive bending moment is not there. It is only imagination, because here maximum negative. Here negative is lesser. So that negative, suppose this is minus 200 here. Here it is minus 120. Then if you use minus 200, how to make minus 120? You need what term? You need what term? Imaginary what term? You need imaginary what term? Notice here minus 120, here minus 200. Actually, if you come from here to here, suppose you look this side, once you use minus 200, here that much BM is not there, because here minus 200 is entire loading considered. So that minus 200, how to make minus 120? You need what term? Tell me, you need what term? You are not answering question. You need what term? To make minus 200 to minus 120, you need what term? No, what term you need? From, if you look this side, no, what term you need? Ishtondu kashtana. To make minus 200 to minus 120, you need what term? You need positive. That is only imagination, correct? Or I will tell a financial matter for you. See, it is case of only expense. Only expense. Monday, start from anywhere. Monday, 100 rupees, some expense. Tuesday, it is 200 rupees. Wednesday, it is 250 rupees. Thursday, expense is 300 rupees. So I want total expense on Thursday. 100 plus 200 plus 250 plus 30. 200, 300, 600, 750 rupees. 300, 850 rupees is the expense. What is the expense here? If you look this side, expense here is 100, 200, 250. If I look this side, expense is 850, then what? Tell me. 850 is wrong. 850 is the expense after spending 300. So tell me, if you see here, if you see this side, expense after Wednesday is, if I look this way, it is 850, then what? Minus you have to do. If this is expense positive, you need minus this expense. How much? 300. It will come, it's worth 550 rupees. Correctly 550 is from this side. Why? You should actually calculate expense from starting day. Today how much expense, tomorrow how much expense, that way. So that is the correct procedure. But if you see the last day expense, if you want one day or a few days earlier expense, what do you have to do? From that expense, you have to remove that extra expense. Clear now? So looks very odd. Therefore, as you, day by day expense increases, same way here. From free end to fixed end, SFBM both increases. So the correct concept technically correct concept is for a cantilever, when you want SFD and BMD, you should always consider which end? Tell me. You should always consider which end? When you want SFD, BMD, you have to always consider which end? Which side? You should consider free end side. Why? Because from free end side, cumulative. Fixed end side, not cumulative. Fixed end side, if you look, it will give you extra answer. So some imaginary removal is required. If it is minus answer, imaginary plus required. If it is plus answer, imaginary minus required. See, for shear force, same way. See, 1 minute here. See, here shear force is, I don't remember yesterday, how much shear force I forgot here. Say 1000. If I want shear force here, it is 1000 minus this much load, because 1000 is this much load. When you reach here, it is only this much load. So this much load is not there. Since it is not there and you took a higher value, you remove that value. Now clear? Clear or not? Because positive to reduce, you need negative value. Negative, hogging bending moment. To reduce, you need positive value. That positive extra imaginary BM comes by VA into something. Actually, VA into something looks very odd actually, correct? See, it looks very odd. That VA into something, writing only looks odd. So, today's class, what I will do is, I will solve 2 questions where I will draw SFD BMD as per practical requirement. Once again from next class onwards, traditional. Remember, I forgot one thing. See, I started yesterday this beam for SFD BMD. No. Once I reach a level here, cantilever, I am stopping cantilever. I will go to next chapter. So, in the SFD BMD course, I will continue for you. There, you can see even overhanging beam also. So many questions are pending. In the overhang also, so many extra questions. I did only some important question to understand. In the cantilever, you can see first question, a point load here, that's all. This you will laugh now. Standard cases, cantilever subjected to point load. Second case, cantilever subjected to point load somewhere else. Third case, cantilever subjected to 2-point load anywhere. Next case, cantilever subjected to UDL over full span. Next case, UDL with point load. Next case, UDL with point load. Next case, cantilever with a couple here. Next case, cantilever with multiple couples here. Next case, cantilever with this type of UVL. Next, cantilever with this type of UVL. Then cantilever with partial UVL. And then combinations. These all I will start uploading one by one. Here not required by basic knowledge clear now. BSK class you need basic knowledge. These are all different varieties. As I keep on uploading, go through it, learn it. Clear? So many questions. By the time our overhanging beam extra problems and cantilevers are over, class number will reach most probably 170, 180. Then I will make it 200. How? By solving some special questions. Like you can draw BMD by special principle by seeing SFD. Because bending moment between 2 points, if you want, suppose you want bending moment here minus bending moment somewhere there is nothing but area of shear force diagram. Some special principles are there. Drawing BMD using SFD, practically not required. Who wants it? Practically you should draw SFD, BMD in a systematic way. They are all special cases. And then sometime SFD given. Using SFD get the loading diagram and draw BMD. Then some conditional problems. So many else will be there. Then I will go through some bracket problems all. That all I will continue. The course will continue. As I upload, go through it. But our BSK class will stop after few cantilevers. BSK class will stop. Then onwards, it will be uploading, not live class. like earlier, I uploaded more than 100 classes. I will continue. Then I can give a note for them. All those who are studying systematically, after class number 99, I will tell them, come to this class, finish some classes, then go back and study extra classes. Clear? Clear or not? You should do it systematically there. These are extra informative classes. Converse problem. Any problem? ಏನು converse problem andre? I don't know what is converse problem. The SFD given to get the loading and BMD, it is not a basic structural knowledge. It is not BSK class. If I do in the BSK class, it is waste of time. It is utter waste of time. Because BSK class we are doing basic structural knowledge. But you will get the question where in the YouTube, I will continue. Okay, now start. Right. Now yesterday's question, you write fresh solution. Fresh solution. Question given. See, note, you need not find reactions. Reactions are not required. You can make a note. Cantilever, you can avoid finding reaction because, why reason? But remember, just because you are not finding reaction, do not tell reaction is not there. So what you have to do? Always remember, even if you are not finding reaction, what happens is, sometimes people make mistake. See, I'll tell you what mistake people make. When they come to fixed end, see, if reactions are not found, when I ask, BM here, look this side, 0. BM here, look this side, 0. Oh, beautiful. BM here is 0 now, fixed end. Fixed end BM is maximum. Why 0 means habit. Oh, nothing here. No. Therefore, remember, before, write the beam once again. Make a note. Total, the load is acting vertically down. So, at A, there is a vertical reaction. This will clearly show that there is shear force here. And all these loads will create clockwise moment about fixed end. To balance, you require anti-clockwise moment here, MA. Now, how much is MA, how much is VA, we don't require. So, always, see, even when I write a cantilever for point load, see, this is 3 meter, this is 10 kilonewton, maximum BM here, 10 into 3. If I look this side, I will tell, see, if you look that side, 10 into 3. But if you look this side, 0. Oh yes, 0. What 0? If you look this side, it is a reacting moment 30 is there. See, that's why even if I don't find reaction, see, I always write like this. To show that it is not calculated, it is there. How much? You can put it later, how much? This point clear? So always at the fixed end, you mark the reaction. Do not calculate it. Clear? Clear or not? You mark the reaction, but do not calculate it. You start from free end side. Clear or not? Answer illa. Clear. Or, see, in case of column and footing, if you remember, some pressure variation, okay, this way. I want SFBM here. I will look this side. If I look this side, see this column reaction, etc., all required. Suppose the variation is like this. Then, if I look this side, if for this cantilever, I take cantilever like this. Then, you get the SFBM, look that side. If you look this side, if for this one, there is a load here and there will be a moment here like this. You have to calculate it. To avoid that one, you look free end side. So remember, for cantilever, for correctly understanding, everything you can look free end side, start from free end side. Okay, start. Now, correct way. First, shear force calculations. See, last time I start from left side, now right side. No right side. And make a note, sign convention. Left up positive, right down is positive. And this is the shear force calculation. Make a note, we will start from free end. That is the correct concept. Start. Come to B. And one thing, if you are looking right side, then left up is positive, right down is positive. So right side, if you see, downward forces are positive, upward are negative. Very careful. Start. First, at B, slightly come inside. At B, shear force at B equal to, look this side. It is this way 30, plus 30 kilonewton. Okay, B over. Come to D. When you come to D, find shear force just to right of D. You should write it. Shear force twice required. So shear force at D just to right of D. First you start from right side. Earlier we did left to right. Now right to left. Just to right of D is, it is already plus 30. When you come to just to right of D, along with plus 30, 8 into 4 will also, in 8 into 4 will create extra shear. Correct or not? See here, 30. When you reach here, not only 30, 8 into 4 will also cause same shear. Answer, how much? Answer fast. Answer fast. I know these things are all actually concept based. Confusion, what to do? These confusion will not be there if everything concept based learned. If you learn everything by pakka concept, such for me there is no confusion. How much? Plus 62. Nodi gottagatte. Plus 62 kilonewton. And shear force at D just to left of D equal to, when you come to just to left of D, plus 30 is there, plus 8 into 4, that plus 62 is there. Also another 40 will go and add to that one. It will add to it, plus another 40. Answer, how much? Plus another 40. Answer, I will tell you later. If you want, you can start from left side, but if you start from left side, you should find the vertical reaction. That's okay. Your choice. Plus 102 kilonewton. Okay, then start. Come to C. Shear force at C, just right, twice required. Just to right of C equal to whatever you got just to left of C, plus 102, and again furthermore shear, plus 8 into 3. 8 into 3. What is the answer? Plus 8 into 3. Answer. Plus extra another 8 into 3. Esto. That shear force plus, see, shear force keeps on increasing. Plus 126 kilonewton. And shear force at C just to left of C equal to that plus 126 up to here. When you reach here, look this side, not only all those load, now extra load of 60 down. So plus another 60 plus 186 kilonewton. Okay, lastly, deep A point. When you come to A, come to just to inside, look this side. Shear force at A equal to how much? Whatever you got, 186. That is the total load from here up to here. Again, furthermore, 8 into 2. Plus 8 into 2. How much answer? Plus how much? Plus 8 into 2. Plus 8 into 2. 202 kilonewton over. Okay, now you can do one thing. Note. Now you can do one thing. At A, when you look right side, shear force is plus 202. So right should be down. When right is down, for positive shear force, Left should be what? Tell me. Right side plus means downward. Left side plus means what? Left side plus means. Left side plus means what? If your shear force positive, to give positive shear force, if you look right side, load should be down. If you look left side, load should be up. So guaranteed this VA should be equal to 202 kilonewton. You can enter now. Tell me how much you got last time VA? Tell me how much you got VA last time? How much VA we got last time? No. How much VA we got last time? Same answer. Okay, over. Or you can do one thing. Calculate the total downward load. That should be upward reaction here. Now, draw shear force diagram. When you draw shear force diagram, you can see all these values. But you can do one thing. Technically, you start from free end side. Or anywhere in future, if you want shear force for a cantilever, you look free end side. Do not look fixed end side. If you look fixed end side, that reaction required, you need not calculate. Or if diagram is there, starting from here, going against the load, see now, 30 positive. Then, 30 positive. Here, I should write SFD, all values are kilonewton, left up, right down, positive. If you plot all 30 positive, increase to 62, jump to 102, increase to what? 186, jump to 202, last year increases to 186 and 126, 186 and 202. Instead of that way, if you want a diagram, what you do is, not for bending moment diagram, you calculate reaction, how much? Total load 202 down. Now, you can start plotting from left side only. 202 up. Then, from here to here, come down by 8 into 2. 186. Come down by 60. 126. Come down by 8 into 3. If you start from this side, into. Come down by 8 into 6. 102. Come down by 40. 62. Come down by 8 into 4. 30. Come down by 30. And remember, this line, all of them, slope is 8, intensity of load, all are parallel. This is shearing force diagram. Now check the answer. 30, 62, 102, increases to 126, suddenly jumps to 186, again increases to 202. So concept wise, this is the shearing force diagram. Full clear? Now, this is when the cantilever is left side fixed problem. In case cantilever is this way, then there is no problem because you start from left side. Start from left side, diagram is very simple. Now clear now? Okay, now start. Bending moment calculation. I remember. Now you have to add something extra. I will not write. Write. I am not writing. You should write. Variation. If you want perfection, write. B to D, linear. D to C, linear. C to A, linear. Linear, linear, linear. Those who are serious will write. Now, bending moment calculation. BM calculation. Sagging positive. Now, remember, correct concept is you start from where effect is lesser, slowly come. So remember, make a note, start from free end, and wherever you are, look towards free end only. Not itara. Start from free end and wherever you are, look free end only. Then it correctly what happens now. Today 100 rupees, tomorrow 80 more, 180 rupees, day of tomorrow 200 more, 380 rupees, next day 500 rupees expense, 880 rupees, next day 1000 expense, 1880 rupees. it comes correctly that way, cumulatively. If you start other way, you have to subtract, etc. Start. Right here. First, all over. Bending moment at B, standard point. Then, bending moment at D. Then, bending moment at C. Lastly, bending moment at A. Correct way. Bending moment at B. Look this side. Unless the couple is there, bending moment is not there. 0. BM at D. Finger here. Look free hand side. 30 into 4. That is hogging BM. 30 into 4. Bracket bada. Minus 30 into 4. Also minus 8 into 4 into 4 by 2. What is the answer? Tell me. What is the answer? 30 into 4. Why negative? Don't ask me. 30 into 4 minus 8 into 4 into 4 by 2. It is minus, it is 184. Minus 184. See, if someone is asking me bending moment, I will tell him bending moment here equal to 30 into 4 plus 8 into 4 into 4 by 2. He may tell, no, not negative, not positive, negative. No, positive. Why? It is hogging. Did I tell hogging, sagging to you? I will tell 184 hogging. I don't require sign convention. If everything is hogging, I will take plus only, but I will remember it is hogging. Okay. That is, if you reach the stage, till the stage, do sign convention. What I will do, some of them, you never try. Start. BMD, danger person. I am really a danger man. Start. 30 into 7 minus. 30 into 7 minus. Again minus. 8 into 7 into 7 by 2. Again minus. 40 into 3. How much answer? First. Answer. ನಿನ್ನೆ ಬಂದಿದೆ ಇದೆಲ್ಲ ರಿಪಿಟೇಷನ್. ಎಷ್ಟು ಆನ್ಸರ್? ಮೈನಸ್ 526. ಆಮೇಲೆ ಕೆಲವರು ಅನಿಸ್ಬಿಡುತ್ತೆ ಸರ್ ಈ ಕಡೆ ದೊಡ್ಡ ಅಂತ, ಈ ಕಡೆ ದೊಡ್ಡ ಸಿ ಇಯರ್. ಲಾಸ್ಟ್ಲಿ ಬಿ ಎಮ್ ಎಟ್ ಎ. ಸಮ್ ವಿಲ್ ಟೆಲ್ 0. ನೋ, ದೇರ್ಸ್ ಎ ಕಪಲ್ ಇಯರ್. ಡೋಂಟ್ ಲುಕ್ ದಿಸ್ ಸೈಡ್. ಕ್ಯುಮ್ಯುಲೇಟಿವ್ಲಿ ಫಿಕ್ಸ್ಡ್ ಅಂಡ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಮೈನಸ್ ಪರ್ಮನೆಂಟ್ಲಿ ಲುಕ್ ದಿಸ್ ಸೈಡ್. ನೋಡಿ ಈ ಥರ ಲುಕ್ ದಿಸ್ ಸೈಡ್. Minus 30 into 9. Again minus 8 into 9 is the total load into 9 by 2. Minus 40 into 5. Minus 60 into 2. Answer. Minus 60 into 2. Answer. Minus 914. Right. All in kilonewton meter. Now come back here. 0 here. Maximum you got 914 here. Saak bidi. Jaga beda. 914. Then here you got 526. ಅದರ ಅರ್ಧ 450. ಸ್ವಲ್ಪ ಜಾಸ್ತಿ. Okay. You got 526 here. Here you got 184 here. 18354. ಸ್ವಲ್ಪ ಜಾಸ್ತಿ. Okay. ಎಷ್ಟದು? 184 here, you got 0 here, parabola, but remember, when you draw parabola here, ಅದು shear force diagram, okay, baseline, this is a bending moment diagram, sagging positive, all values are k in meter. Here, what you should do? You should have little slope there because shear force is there, slight slope is there, slope will increase, slope will further increase. Because why? Slope here 30, this side slope 62, this side slope 102, this side slope 126, this side slope 186. ಸ್ವಲ್ಪ ಸರಿಯಾಗಿ ಬಂದಿಲ್ಲ ಅದು, ಇನ್ನು ಸ್ಟೀಪ್ ಆಗಿ ಬರುತ್ತೆ. ಹಂಗೆ ನೋಡಿ, ಈ ಸ್ವಲ್ಪ ಸ್ಲೋಪ್ ಕಮ್ಮಿ. ಇದು ಹಿಯರ್ ಸ್ಲೋಪ್ ಎಷ್ಟು? 202. ದಿಸ್ is the bending moment diagram. This is correct. Now you can do one thing. Since the bending moment here came minus 914, if I look that side, you should get a bending moment of minus 914. If you want a negative value, moment there should be like this. So now you can tell This value is 914 kilonewton meter. If you want, you can enter by seeing the bending moment. Full clear? Fast. This is technical correct way of SFD&BMD for cantilever. It gives you correct idea from the free end to fixed end when you travel how SFBM varies. Full clear? Okay. Now I will go to more questions. I remove this one now. Okay. Now important now. Okay. I will first take up a question where right side is fixed now to understand. Okay. I will take a cantilever here. Right side fixed. And now I will change the loading. I will not put point load here. I will put a anti-clockwise couple here of 20 kilonewton meter. Then I will put a UDL after a gap of something. UDL. In between I will put a point load. Then from here I will put one uniformly varying load. This is the cantilever. This intensity is 0 to 30 kilonewton per meter. This point load is 100 kilonewton. This UDL is 18 kilonewton per meter. The total length of beam is 5 meter. ಇದು 1 ಮೀಟರ್, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ 1.8 ಮೀಟರ್ ಎಷ್ಟು ಉಳಿತು ಇವಾಗ. ಆ್ಯಂಡ್ ದೆನ್ ದಿಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಈಸ್ ಒಂದು 2.8 ಅಂದರೆ ಒಂದು 2.8 ಉಳಿತೀಗ 1.1 ಮೀಟರ್ ಆಯಿತು. ದಿಸ್ ಅ ಬೀಮ್. ಎ ಬಿ ಇಸ್ ದ ಬೀಮ್. I want SFD&BMD for this beam. First I want usual general way. Means what? No concept required. But concept required, that practical requirement of come from free end to fixed end, that you don't apply. Okay, start. So therefore first go for traditional way of SFD&BMD. Tell me. If you go to traditional way of SFD&BMD, tell me what first you require. First, if you go to traditional way of SFD&BMD, what first you require? Answer. First, what you require? If you go traditional way, what first you require? Begalbeku. First you require what? Traditional way, systematic way, or complete basic concept point of view. No practical oriented. Support reactions. You need support reactions. For that, do one thing, right? B is fixed support. Therefore, at B, reacting moment MB and vertical reaction VB. Draw the beam once again. When you draw the beam once again, here, draw one more sketch. There. Load is acting down, reaction is up, VB. Then all these loads will create, including couple, in this direction. So balancing you require like this. This is your MB. Correct? Clear or not? If this is not clear, class cannot be continued. How I assume the reaction? Clear? This is the assumption for support reaction. Little fast you are finished now. This question I want today to complete. I want to complete today. Start. Take moment about which point? Tell me. Don't take left hand. I told you always take moment about the point where unknown reactions are there. Sigma m about B equal to 0. Take clockwise positive. I told 1000 times. Sigma m is complete beam, not one side. If I take moment here, see, plus MB y clockwise, minus 20 into, no into, minus 20, no into, minus. This is 5 meter, this 1.1. Anybody can tell me what is this distance and total length here required? From 5, subtract 1.8, subtract 1. It will come 1.8, only 2.8. This will become 2.2 meter, correct? That will become 2.2 meter, correct? That length of UDL will become 2.2, correct? No. The length of UDL, oh, this is 1 meter given, not 1 meter. I am changing to, not 1 meter. I am changing to 1.4 meter. Why? I do not want this point load at center of the UDL. For some reason, the question is changed. This is 1.4. So tell me, what is this distance? Fast. What is this distance? Bega. A cut distance. And change ಮಾಡಿದೆ 1.1 I change to 1.4. What is the small cut distance? That small cut distance 0.8 meter. You calculate, enter. Okay, now minus 20 minus 18 into 2.2 is the total UDL. 18 into 2.2 into moment about this point 1.8 plus 2.2 by 2. Also minus 100 is the point load into 1.8 plus 0.8 is 2.6. Also minus moment of this triangle load half into 1.8 into 30 is the total load into moment about this point. I will not waste time. It is 2/3 of 1.8. 2/3 of 1.8 equal to 0. Without any mistake, tell me the MB value. Fast. Tell me correctly MB value. Bega. Without any mistake, correctly tell the MB value. And ಬೇರೆ ಕೆಲಸ ಇದೆ ಇಲ್ಲಿ ಈಗ. ಯಾಕೆ? I should prepare the beam here. Okay, ಇದು ಬರಿತೀನಿ. Okay, ಸಾಕ್ಬಿಡಿ. You tell me correctly MB value. 1 meter. ಅದಾದಮೇಲೆ 1.4 ಸ್ವಲ್ಪ ಜಾಸ್ತಿ 1.4 1.4 ಆದಮೇಲೆ 0.8 ಇಲ್ಲೇ ಬರುತ್ತೆ 0.8 ಆದಮೇಲೆ 1.8 if this is 1.4 1.8 will come up to here. Okay, reasonably okay, scale maintained. So if I put cut distances, this is 1 meter, this is 1.4 meter, this is 0.8 meter, this is 1.8 meter. Here uniformly varying load of this type. You tell the answer to me when I am preparing the diagram here. This is 30 kilonewton per meter, and then from here to here there is a UDL of 18 kilonewton per meter. There is a point load here of 100 kilonewton. Here there is an anti-clockwise couple of 20 kilonewton meter. I will take the point as A, this point is B, this I will call C, this I will call D, this I will call E. E. ಆಯ್ತು. ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ರೆಡಿ. MB ಕರೆಕ್ಟಾಗಿ ಹೇಳಬೇಕು, ಸುಳ್ಳು ಹೇಳಬಾರ್ದು. 160 MB ಎಷ್ಟು 427.24. ಥ್ಯಾಂಕ್ ಯು. ಪ್ಲಸ್ 427.24 kilonewton meter positive. Then sigma V equal to 0, take upward positive. Any answer? Upward positive. Plus VB minus 18 into 2.2 is the total UDL minus 100 minus that uniformly varying load half into 1.8 into 30 equal to 0. Tell correctly the VB value. Any answer? Ilondu reacting moment MB clockwise I got 427.24 kilonewton meter, and there is a vertical upward reaction, red color, VB of, you ಹೇಳಬೇಕು ಆನ್ಸರ್ ಎಷ್ಟು ಅಂತ. VB is 166.6 kilonewton. Now right here ಕೆಂಪು ಬಣ್ಣ 166.6 ಕಿಲೋಮೀಟರ್. ಕ್ಯಾಲ್ಕುಲೇಟ್ ವ್ಯಾಲ್ಯೂ ನೋಡಿ. ನಾವು ಐ ಟೋಲ್ಡ್ ಯು 1000 times positive sign indicates assumed direction is correct. Now B means ready for SFD&BMD, correct? Now make a note. If you do traditionally, you find reaction. Later I will do without traditionally. If not today, tomorrow, no problem. Agila andre. But tomorrow means I will prepare and write something already. Start ಮಾಡಿ. All I will rub out now. No mistake so far. If you make a mistake, it becomes problem. Why? Preparing is very difficult. Traditionally means you start shear force calculation. Shear force calculation first. And remember now, this time, fortunately, traditional calculation and practical calculation for shear force both are same. Tell why? Tell me. Tell why? This question, fortunately, traditional calculation or practical oriented calculation both are same, because traditionally you start from left side. Practically also you start from left side. Okay, free end. Clear or not? Therefore, shear force calculation same for both traditional calculation or your practical oriented calculation. Clear? Fortunate. ಅಂತ ಟೈಮ್ ಸೇವ್ ಆಯಿತು. Clear or not? Yes. ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಬೇಗ. shear force is left up, right down, positive. ಬೇಗ ಬೇಗ ಹೇಳಬೇಕು. at A answer. shear force at A. ಬೇಗ ಹೇಳಿ ಆನ್ಸರ್ ಎಷ್ಟು? Look this side. Come slightly inside. Look this side. Couple is not considered for shear force. Answer. ಎಷ್ಟು? shear force at A. ಇಷ್ಟೊತ್ತು ಬೇಕಾ ಒಂದು shear force ಕೊಡೋಕ್ಕೆ? 0 ಆಗೋಯ್ತು. Then C ಪಾಯಿಂಟ್ ಅಲ್ಲಿ shear force at C. Tell me here. Look this side. Previous value is 0. Then after previous value nothing is there. Here also 0. Correct? Here also 0. Or remember, for a cantilever from free end till you start the load, till the loading starts, shear force is not there. Clear now? Till the load starts, shear force is not there. Okay, now after that one, come to D. D shear force you have to do twice. Why? Just like that. First right. Shear force at D just to left of D equal to previous point we got 0 minus from here to here down of 18 into 1.4. Big answer. 18 into 1.4. Answer. Why minus? Left side down is negative. Shear force keeps on increasing because full negative shear force. That's all. See, wherever you see here, look this side, negative shear force, so it increases. Minus 25.2. Minus 25.2 kilonewton. And shear force at D just to right of D equal to minus 25.2 minus 100. It answer minus 125.2 kilonewton. Then after D, next point is E. Only one calculation. Shear force at E equal to whatever you got here minus 125.2 just to right of D. From there to here, come down by 18 into 0.8. ಇದೆಲ್ಲ ಬೇಕಾಷ್ಟು ಬಾರಿ ಆಗಿದೆ. ಇದೆಲ್ಲ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಐ ಶುಡ್ ನಾಟ್ ಟೆಲ್ ನೌ. I should stop this one, tell you only do it. Actually waste of time. Someone will tell how many times he told this one. Again he is explaining. Answer. Minus 139.6. Okay. Lastly, shear force at B. Shear force at B equal to whatever you got here minus 139.6 minus this much load, that is half into 1.8 into 30. Answer. It has to come minus 166.6 kilonewton. Tell why? Because if you come just inside. If you look right side, the shear force is right up 166.6, that is negative. It has to come. Tallying, yes, over. Now, some note, right? Variation of shear force. Variation. I am not writing, I am dictating. You should write. A to C, there is no shear force. ಯಾರು ಅಂತಾರೆ ವೇರಿಯೇಷನ್ ರೇ ಇಲ್ಲ ಅಂದಮೇಲೆ ಏನ್ರಿ ವೇರಿಯೇಷನ್ ಅದು ವೆನ್ ದರ್ ಇಸ್ ನೋ ಶಿಯರ್ ಫೋರ್ಸ್ ವಾಟ್ ವೇರಿಯೇಷನ್ ದೇರ್ ಫೋರ್ ಒನ್ ಥಿಂಗ್ ಗ್ಯಾರಂಟೀಡ್ ಟೆಲ್ ಆನ್ಸರ್ ಫ್ರಮ್ ಎ ಟು ಸಿ ದೇರ್ ಇಸ್ ನೋ ಶಿಯರ್ ಫೋರ್ಸ್ zero shear force means bending moment will be what later bending moment will be what later bending moment will be what later later bending moment will be no shear force. You know it, you forgot most probably. No shear force means bending moment will be at vega martoita all the principle I told. No shear force means constant, and that is also called as that is also called as some name. When BM is constant without, that is when there is no shear force, that is called technically ಏನಂತ ಅದಕ್ಕೆ ಏನೋ ಒಂದು ಹೆಸರಿದೆಯಲ್ಲ ಅದಕ್ಕೆ ಏನು ಮರ್ತೋಯ್ತಲ್ಲ ಜ್ಞಾಪಕ ಆಗ್ತಲ್ಲ ಓದ್ಕೊಂಬರಲ್ಲ ಎಲ್ಲೋ ಬರೆದಿಟ್ಟಿದ್ದೀನಿ ಕಾಣ್ತಾ ಇಲ್ಲ ಎಲ್ಲೋ ಬರೆದಿಟ್ಟಿದ್ದೀನಿ ಎಲ್ಲಿ ಬರೆದಿಟ್ಟೆ ನೀವು ಹೇಳಿದ್ರೆ ಹೆಲ್ಪ್ ಆಗತ್ತೆ ನನಗೆ ಎಲ್ಲೋ ಬರೆದಿಟ್ಟಿದ್ದೀನಿ ಥ್ಯಾಂಕ್ ಯು ಪ್ಯೂರ್ ಬೆಂಡಿಂಗ್ ಗೊತ್ತಾಯ್ತು ಬಿಡಿ ಮರ್ತೋಗಿತ್ತು ಏನು ಮಾಡ್ತೀನಿ ಆಯ್ತು ಪ್ಯೂರ್ ಬೆಂಡಿಂಗ್ ಈಗ ನೆಕ್ಸ್ಟ್ ಫ್ರಮ್ ಸಿ ಟು ಡಿ ಲೀನಿಯರ್ D to E linear, E to B parabola of second degree. You should write. Those who are serious should write here. No shear force here. C to D linear, D to E UDL linear, E to B parabola of second degree. Right. Now go back and draw shear force diagram. What is shear force diagram? ವಿ ಬಿ ಅಷ್ಟು ಜಾಗ ಬೇಡ ನಿಮಗೆ, ಸುಮ್ಮನೆ ಕೂತ್ಕೋ. ಊರೆಲ್ಲ ಬರ್ತಾನೆ ನೋಡಿ, ಊರೆಲ್ಲ ಇವರಿಗೆ ಜಾಗ ಬೇಕಂತೆ. ಸಾಕು. ಈಗ ಐ ವಿಲ್ ಡ್ರಾ ದ ಬೇಸ್ ಲೈನ್ ಫಾರ್ ಶಿಯರ್ ಫೋರ್ಸ್ ಡಯಾಗ್ರಾಮ್. ನೋಡಿ, ಶಿಯರ್ ಫೋರ್ಸ್ ಡಯಾಗ್ರಾಮ್, ಆಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಆರ್ ಕಿಲೋನ್ಯೂಟನ್, ಲೆಫ್ಟ್ ಅಪ್ ರೈಟ್ ಡೌನ್ ಪಾಸಿಟಿವ್. ಸ್ಟಾರ್ಟ್. ನೌ ಡೂ ಒನ್ ಥಿಂಗ್, ಡು ನಾಟ್ ಸಿ ದೇರ್, ಯು ಟೇಕ್ ಯುವರ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್. ನೋಡಿ, ಹಿಯರ್ ನೋ ಶಿಯರ್ ಫೋರ್ಸ್, from here up to here nothing is there. From here to here come down by 18 into 1.4. Answer. I'll not ready. Don't see there. You see here 0. When you reach here, down by 18 into 1.4. This ordinate, Vega. This ordinate. I'll not ready. You take your calculator. 18 into 1.4. ಜಾಗ ಕಮ್ಮಿ ಇದೆ, ಇಲ್ಲಿ ಬರ್ತಾ ಕಮ್ಮಿ ಇರುತ್ತೆ ಈ ಥರ. ಹೇಳಿ ಎಷ್ಟು? ಅಲ್ಲೇ ಇದೆ ಆನ್ಸರ್. 25.2. ನಾನೇ ಬರಿತೀನಿ, ನೀವು ಹೇಳೋದಿಲ್ಲ. 25.2. ಸಡನ್ಲಿ ಕಮ್ ಡೌನ್ ಬೈ 100. 25, 50, 75, 100. ದೆನ್ ಫ್ರಮ್ ಹಿಯರ್ ಟು ಹಿಯರ್ ಅಗೈನ್ ಕಮ್ ಡೌನ್ ಬೈ ಹೌ ಮಚ್? 18 into 0.8. ಹೇಳಿ ಆನ್ಸರ್. ಆ್ಯಂಡ್ ರಿಮೆಂಬರ್ that line should be parallel to this line. Why? For this line slope is 18, for this line also slope is 18. These two should be parallel. Answer. ನೀವು ಇವಾಗ ಹೇಳ್ತಾ ಇದೆಯಾ ಎಷ್ಟೆಷ್ಟು ಹೊತ್ತಾದ್ಮೇಲೆ ಇದು ಪ್ಯಾರಲಲ್. ಈ ಆನ್ಸರ್ ಬೇಕು, ನೀವು ಹಳೆ ಆನ್ಸರ್ ಹೇಳ್ತಾ ಇದ್ದೀರಾ, ಅಲ್ಲೇ ಇದೆ. ಇದು 125.2, ಇದು ಮರ್ತೋಯ್ತು. ಅದು 139. ಎಷ್ಟದು? 6. ಕರೆಕ್ಟಾ? ದೆನ್ ಫ್ರಮ್ ಹಿಯರ್ ಟು ಹಿಯರ್ ಪ್ಯಾರಾಬೋಲಾ ಆಫ್ ಸೆಕೆಂಡ್ ಡಿಗ್ರಿ. ನೌ ಬಿ ಕೇರ್ಫುಲ್. ಟೆಲ್ ಮಿ, intensity is maximum here, intensity is 0. So slope of the shear force diagram as you go that way should increase or decrease. Bega, as you go that way slope of the shear force diagram should increase or decrease. Bega, ಇದು ಇನ್ನೊಂದು ಬಾರಿ ಹೇಳೋದಿಲ್ಲ, ಬಿಕಾಸ್ ದಿಸ್ UVL ಹ್ಯಾಸ್ ಗಾಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇಂಟೆನ್ಸಿಟಿ ಇಯರ್, ಝೀರೋ ಇಂಟೆನ್ಸಿಟಿ ಇಯರ್. ಸೊ ಫ್ರಮ್ E to B, ಇಫ್ ಯು ಗೋ ದಟ್ ಸೈಡ್, ದ ಸ್ಲೋಪ್ ಆಫ್ ಶಿಯರ್ ಫೋರ್ಸ್ ಡಯಾಗ್ರಾಮ್ ಶುಡ್ ಇನ್ಕ್ರೀಸ್ ಆರ್ ಡಿಕ್ರೀಸ್. ಇದೆಲ್ಲ ಬರ್ಕೋಬೇಕು ನೀವು. ದೀಸ್ ಆಲ್ ಯು ಹ್ಯಾವ್ ರೈಟ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಕರೆಕ್ಟ್ಲಿ. ಇಫ್ ಯು ಆರ್ ಇಂಟ್ರೆಸ್ಟೆಡ್ ಇನ್ ಲರ್ನಿಂಗ್ ಆಲ್ ದಿಸ್ ಯು ಹ್ಯಾವ್ ರೈಟ್. ಹೇಳಿ ಬೇಗ, ಆನ್ಸರೇ ಇಲ್ಲ. ಇದು ಎಷ್ಟು, ಹೌ ಮೆನಿ ಟೈಮ್ಸ್ ಐ ಟೋಲ್ಡ್, ಐ ಡೋಂಟ್ ನೋ. ಇಟ್ ವಿಲ್ ಡಿಕ್ರೀಸ್. ಡಿಕ್ರೀಸಿಂಗ್ ಸ್ಲೋಪ್ ಈಸ್ ಇಟ್ ದಿಸ್ ವೇ ಆರ್ ಈ ಥರನ, ಅಲ್ಲ ಈ ಥರನ, ಯಾವುದು ಹೇಳಿ? ಇದು 139.6. ನೀನು 139.6 ಕೂತ್ಕೊಳ್ಳಿ ಈಗ ಹೇಳಿ. ಆ್ಯಂಡ್ ವೆನ್ ಯು ರೀಚ್ ಹಿಯರ್, ಕಮ್ ಡೌನ್ ಬೈ another half into 1.8 into 30, that ordinate is surely to 166.6 guaranteed. Now here to here, one chance, nodi 160, one chance is curve is like this, other chance is curve is like this. Tell me, first correct or second correct? One chance is curve is like this. Second, if the curve is this way, nodi, if the curvature is this way, here slope is 0, here slope is maximum. If curvature is this way, here slope is maximum, here slope is 0. Which is correct? Second correct. Yake? Here slope equal to no. So therefore what is correct? This is the curve. Ee tara bantu. Iga tell me, if I draw tangent here, what is the slope here? If I draw tangent here, what is the slope? Fast. These all you should write. Those who are serious, write some note. Tell slope here. Slope here is intensity here. Esto. If I draw this way, slope here, 0. If I draw a tangent here, then tell the slope. For this side, slope is 18 UDL. For that side, intensity is how much? Tell me. For that side, intensity is 2. What is the intensity here for this side? Intensity here for this side, 30. 30 is more than 18. So, slope of this curve is more than slope of the straight line or less than slope of the straight line. Heading. Slope of the straight line, this slope of this curvature here should be more than slope of the straight line, that or less. Idike slope 18. For this one slope is 30. The slope of the tangent, if you draw there, for the tangent, slope for the curvature part should be 30. For this line, slope is 18. So for the curved side, slope should be what? More or lesser? ನೀವು ಆನ್ಸರ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಕೇಳಿದ್ದೇನೆ ಪುನಃ ಕೇಳ್ತಾ ಇದ್ದೀನಿ. ಫಾರ್ ದ ಕರ್ವ್ಡ್ ಸೈಡ್, ಸ್ಲೋಪ್ ಈಸ್ ಮೋರ್ ಆರ್ ಲೆಸ್ಸರ್? ಮೋರ್. ಆರ್ ನೋಡಿ, ಇಫ್ ದಿಸ್ ಈಸ್ ದ ಲೈನ್ ಹಿಯರ್, ನೋಡಿ ಈಗ ಸ್ಲೋಪ್ ಎಷ್ಟು? ಫಾರ್ ದಿಸ್ ಒನ್ ಟ್ಯಾನ್ ಥೀಟಾ ಈಕ್ವಲ್ ಟು ಎಷ್ಟು? 18. ದಿಸ್ ಸ್ಲೋಪ್ ಶುಡ್ ಹ್ಯಾವ್ more slope. This is 18, and for this one it should be what? Tan theta should be 30. The king bantu. By chance the intensity is not 30 here, intensity is exactly 20. Agenagta ittu. How much is slope here? Same slope for this one. Clear now? Then this line should be tangent to that one. Whatever, if the intensity is 18 here, if the intensity is 18 here, whatever is slope for this one, same slope here. Clear or not? Then that this line should be tangent to that curve. Clear? Powerful concepts. Clear or not? This all I told you. Make a note. Suppose this is 18 only, then how it goes here? Same way. Nodi, this should be tangent. Both of them should have same slope. Yes. Or suppose this is not 30, if it is 12, aga this is straight line. Tell me, for the curved side, slope is more or lesser? Heading. Slope is more or lesser? Idu slope idikke, nodi idikke slope more or lesser? Suppose this intensity is 12 or less than 18, then the curved side slope should be more or lesser. ಬೇಗ ಹೇಳಿ, ಆಗೋಯ್ತು. The curved side part slope should be lesser. Make all these note. Those who are regular to the class from beginning, all the concept clear. ಹೇಳಿ ಬೇಗ. All the concept clear. Those who are irregular, don't follow everything from every class number 1. If you don't study and randomly come to the class, if not clear, you have to blame yourself only. Those who are regular and observe everything I tell, concept clear? Okay, over. Now with this one, shear force over. Now write a note here. Observe the shear force diagram. Yes, answer. Observe. Any point shear force diagram changes baseline or where zero shear force is there, that is plus to minus change. Illa. Change is not there. Oh, then that's all. Keep quiet. Go to what? Then that's all. Don't go for that location, etc. Nothing is there. Go to what? Go to. Directly go to. Go to where? If it is not there, keep quiet. Go to. ಆಗೋಯ್ತು. ಶಿಯರ್ ಫೋರ್ಸ್ ಡಯಾಗ್ರಾಮ್ ಓವರ್. ಗೋ ಟು SFD ಡ್ರಾ ಮಾಡಿ ಆಯ್ತು. ಆಫ್ಟರ್ ಡ್ರಾಯಿಂಗ್ SFD, ಅಯ್ಯೋ, ಗೋ ಟು BMD. ಫುಲ್ ಅಯ್ಯೋ ಇಲ್ಲ, ನಾನು ಹಿಂಗೆ ಬರೆದ್ಬಿಟ್ರೆ ನಾನೇನಂತೀನಿ ಗೊತ್ತಾ, ಲೆಫ್ಟ್ ಡೌನ್ ಪಾಸಿಟಿವ್, ರೈಟ್ ಅಪ್ ಪಾಸಿಟಿವ್ ಅಂತೀನಿ. ಬಟ್ ಕೆಲವೊಂಥರ ಸಾರ್ ಬೇಡ ಸಾರ್, ಆಯ್ತಪ್ಪ, ಏನೋ ಅಭ್ಯಾಸ ಬಲ ಮೈನಸ್ ಹಾಕ್ಕೊಂಡು ನೋಡಿ, ಪ್ರತಿಯೊಂದಿಗೂ ಡಿಪೆಂಡ್ ಮಾಡ್ತೀನಿ ನಾನು. ತಪ್ಪು ಮಾಡು ಡಿಪೆಂಡ್ ಮಾಡೋಕ್ಕೆ ಬರುತ್ತೆ ನನಗೆ. ಆಯಿತು, ಈಗ ಆಯ್ತು ಬಿಡಿ, ಇದು ಮಿಸ್ಟೇಕ್ ಅಲ್ಲ, ಮರೆತುಬಿಟ್ಟೆ. ಈಗ ಗೋ ಟು ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್ ಡಯಾಗ್ರಾಮ್. ನೋಡಿ, ಮೇಕ್ ಎ ನೋಟ್. ಇವತ್ತು ನೀವೇ ಮಾಡಬೇಕು, ಇವತ್ತು ಹೇಳ್ತೀಯ ನಾನು. ಮೇಕ್ ಎ ನೋಟ್. ಫಸ್ಟ್ ಐ ವಿಲ್ ಗೋ ಫಾರ್ ಟ್ರೆಡಿಷನಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್. ಟ್ರೆಡಿಷನಲ್ ನೋಡಿ, ಈಗ ಟ್ರೆಡಿಷನಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಸ್ಟಾರ್ಟ್. ಬಿ ಸ್ಯಾಗಿಂಗ್ ಪಾಸಿಟಿವ್, ಆಮೇಲೆ ಇಲ್ಲೇ ಮುಗಿಸ್ಬಿಡ್ತೀನಿ. ಈಗ BM at A, couple is there, but only one calculation. Why? Extreme end. Come slightly inside. Look this side. -20. ಆಗೋಯ್ತು. -20 kN meter. Come to C. BM at C. Look this side. -20 kilonewton meter. Come to D. BM at D. Better still look this side. ನೋಡಿ, all these three you look left side. ಹೇಳಿ ಆನ್ಸರ್. BM at D -20, then -18 into 1.4 into what? 1.4 by 2, 4 by 2, also -100 into 0.8. Answer. All this one, do traditional calculation. Answer. ಬೇಗ ಬೇಗ. ಎಷ್ಟು? ಮೈನಸ್ ಕಾಣ್ತಾ ಇಲ್ಲ. 39, ಯಾರೊಬ್ರಿಗೆ 39, ಒಬ್ರಿಗೆ 37, ಹಾಗೆಲ್ಲ ಬರೋಂಗಿಲ್ಲ, ಒಂದೇ ಆನ್ಸರ್ ಬರಬೇಕು. ಓ, ಅವರೇ ಚೇಂಜ್ ಮಾಡಿದ್ರಾ? -37.64. ನೀವೇ ತಪ್ಪು ಮಾಡಿದ್ರಾ? -37. 100 into 0.8 80 ಇದಲ್ಲ. ಅಯ್ಯಯ್ಯೋ, ಇದ್ಯಾವ ಕ್ಯಾಲ್ಕುಲೇಟ್ರ್? 100 into 0.8 80 ಬರ್ತಾ ಇದೆ ಅಲ್ಲಿ. ಅದೇಗೆ -37? ಯಾವುದು ಕ್ಯಾಲ್ಕುಲೇಟ್ರ್? 100 into 0.8 80 ಇದೆ ಅಲ್ಲಿ. ಎಷ್ಟು ಆನ್ಸರ್? ಅಲ್ಲೇ ಗೊತ್ತಾಗತ್ತೆ. 100 into 0.8 80 ಬರುತ್ತಲ್ಲ, ಆಲ್ರೆಡಿ 8 ಇದೆ. ಎನದರ್ ನೆಗೆಟಿವ್ಸ್ ಆರ್ ದೇರ್. ಎಷ್ಟು ಆನ್ಸರ್ ನೋಡಿ? ಅದರ್ಸ್ ಆರ್ ನಾಟ್ ಕಾಂಟ್ರಿಬ್ಯೂಟಿಂಗ್. ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಟೈಮ್ ವೇಸ್ಟ್. ನಂಗೆ ಅಷ್ಟು ಟೈಮು ಇಲ್ಲ, ನನಗೆ ಬೇಗ ಮುಗಿಸ್ಬೇಕು ನೋಡಿ. ಪೀಪಲ್, ಇಫ್ ಯು ಡೋಂಟ್ ರೆಸ್ಪಾಂಡ್, ಸೋ ಮೆನಿ ಆರ್ ದೇರ್, ದೇ ಡೋಂಟ್ ಕಾಂಟ್ರಿಬ್ಯೂಟ್. ಓ, ಡಿ ಎಲ್ ಇಲ್ಲ, ಓಕೆ, ನಾನು ಇಲ್ಲಿ ಮಾಡ್ತಾ ಇರೋದಾ? ಅದು ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್ಗೆ. ಸಾರಿ, ಪ್ರಿಂಟ್ ಮಿಸ್ಟೇಕ್. ನಾನು ಮಾಡ್ದೆ, ಏನು ಮಾಡೇ ಗೊತ್ತಾ? ಇಲ್ಲಿ ಬಂದ್ಬಿಟ್ಟೆ ನೋಡಿ. -20 -18 into 1.4 into 1.4 by 2 ಅಷ್ಟೇ. ಎಷ್ಟು ಆನ್ಸರ್? ಮಿಸ್ ಪ್ರಿಂಟೆಡ್. ನಾನು ಮುಂದಕ್ಕೆ ಹೋಗ್ಬಿಟ್ಟೆ. I told here, when I went there, I saw other point. ನಾನು ಮಾಡುವ ತಪ್ಪು, ನೀವು ಮಾಡೋಗಿಲ್ಲ. ನೀವು ಸಪೋಸ್ ರಾಂಗ್ ಕೊಟ್ಟರು ಡಯಾಗ್ರಾಮ್ ಮಾಡ್ತಾ ನಾನೇ ಕಂತೀನಿ ಯಾರಿಗ್ರಿ ಆನ್ಸರ್ ಬಂತು ಅಂತೀನಿ ನೋಡಿ, ನನಗೆ ಗೊತ್ತಾಗತ್ತೆ. ಎಷ್ಟು? -37.64, ಓಕೆ, ಕಿಲೋ ನ್ಯೂಟನ್ ಮೀಟರ್. ಓಕೆ, ನಾವು ಕಮ್ ಟು ಇ ನೋಡಿ, ಕಮ್ ಟು ಇ, ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಎಟ್ ಇ ನೋಡಿ. ಇಫ್ ಯು ಆರ್ ಡೂಯಿಂಗ್ ಟ್ರೆಡಿಷನಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಅಟ್ ಇ, ಬೆಟರ್ ಲುಕ್ ಯಾವ ಕಡೆ ಹೇಳಿ? If you are doing traditional calculation, bending moment at E, you look this side. This side. ಎಷ್ಟು ಆನ್ಸರ್? -427.24, then plus 166.6 into 1.8 minus half into 1.8, half into 1.8 into ಎಷ್ಟದು 30 is the total load, moment about this point into 1/3 of 1.8. Answer ಹೇಳಿ. If you are doing traditional calculation, you can look right side. ನಾನು ಹೇಳ್ತೀನಿ ಯಾಕೆ ಅಂತ, 2 in 1 ಮಾಡ್ತೀನಿ ನಾನೀಗ. ಇಲ್ಲೆಲ್ಲ ಲೆಫ್ಟ್ ಸೈಡ್ ನೋಡಿ, ಇದು ಈಸಿ ಆಲ್ಸೋ, ಲೆಫ್ಟ್ ಸೈಡ್, ಫ್ರೀ ಹ್ಯಾಂಡ್ ಸೈಡ್. ಆನ್ಸರ್ -143.56, ಕರೆಕ್ಟಾ? 56 ಕಿಲೋ ನ್ಯೂಟನ್ ಮೀಟರ್. ಈಗ ಬರೀ. ಆರ್ ಇಫ್ ಯು ವಾಂಟ್ ಪ್ರಾಕ್ಟಿಕಲ್ ನಾಲೆಜ್ ಏನು ಮಾಡಿ ಹೇಳಿ? ಈವನ್ ಹಿಯರ್ ಆಲ್ಸೋ ಪ್ರಾಕ್ಟಿಕಲ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ, ಲುಕ್ ವಿಚ್ ಸೈಡ್? ಬೇಗ ಹೇಳಿ. ಸಪೋಸ್ ಹಿಯರ್ ಇಫ್ ಯು ವಾಂಟ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ, ಲುಕ್ ವಿಚ್ ಸೈಡ್? ನಿಮ್ಮಿಷ್ಟ. ಹೇ, ಐ ಟೋಲ್ಡ್ ಯು, ಪ್ರಾಕ್ಟಿಕಲ್ ನಾಲೆಜ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ವಿ ವಾಂಟ್ ಕಾನ್ಸೆಪ್ಟ್, ಲುಕ್ ವಿಚ್ ಸೈಡ್? ಈವನ್ ಹಿಯರ್ ಆಲ್ಸೋ ಲುಕ್ ದಿಸ್ ಸೈಡ್ ನೋಡಿ, ಈ ಕಡೆ ನೋಡಿ. ಈ ಕಡೆ ನೋಡಿದ್ರೆ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ -20 -18 into total is 2.2, 18 into 2.2 into 2.2/2 also -100 into 0.8. ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ? ಇಷ್ಟೇ ಬರಬೇಕು, ನೋ ಅದರ್ ವೇ, ಇಟ್ ಹ್ಯಾಸ್ ಟು ಕಮ್ ಸೇಮ್. ಎಷ್ಟು ಆನ್ಸರ್? ಈ ಬರೀರಿ. ಟ್ರೆಡಿಷನಲ್ ಮೀನ್ಸ್ ಲುಕ್ ಲೆಫ್ಟ್ ಸೈಡ್, ಲುಕ್ ಲೆಫ್ಟ್ ಸೈಡ್, ಫ್ರೀ ಹ್ಯಾಂಡ್ ಸೈಡ್, ಫ್ರೀ ಹ್ಯಾಂಡ್ ಸೈಡ್, ಫ್ರೀ ಹ್ಯಾಂಡ್ ಸೈಡ್. ಆಯ್ತು, ಬೇಗ ಬೇಗ. ಸೇಮ್ ಆನ್ಸರ್. ಎಷ್ಟು? -143.56. ಲಾಸ್ಟ್ಲಿ ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್ ಅಟ್ ಬಿ. ಇಫ್ ಯು ಡೂ ಟ್ರೆಡಿಷನಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್, ವೆರಿ ಈಸಿ, ಲುಕ್ ದಿಸ್ ಸೈಡ್, -427.24 ಆಗೋಯ್ತು ಬರೀ ಕಿಲೋ ನ್ಯೂಟನ್ ಮೀಟರ್. ಆರ್ ಇಫ್ ಯು ಡೂ ಪ್ರಾಕ್ಟಿಕಲ್ ನಾಲೆಜ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ, ನೌ ಯು ರೈಟ್, ನೀವು ಬರಿಬೇಕು. ಬರಿತೀರಾ? ಹೇಳ್ತೀನಿ ನೋಡಿ. ಇಫ್ ಯು ಸಿ ಪ್ರಾಕ್ಟಿಕಲ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ, ಹಿಯರ್ ಆಲ್ಸೋ ಲುಕ್ ಲೆಫ್ಟ್ ಸೈಡ್. ಆಗ ಹೇಳಿ ಈ ರಿಯಾಕ್ಟ್, ದೆನ್ ಯು ನೀಡ್ ನಾಟ್ ಫೈಂಡ್ ದ ರಿಯಾಕ್ಷನ್ಸ್. ಕ್ಲಿಯರ್? ದೆನ್ ಯು ನೀಡ್ ನಾಟ್ ಫೈಂಡ್ ದ ರಿಯಾಕ್ಷನ್ಸ್. ದೆನ್ ಆನ್ಸರ್ ಈಸ್, you should write -20 -18 into 2.2 is the total load into 1.8 plus half of 2.2 minus 100 into 2.6 minus half into 1.8 into 30 into 2/3 of 1.8. What all I told right here. I will check the answer. ಬೇಗ ಚೆಕ್ ಮಾಡ್ತೀನಿ. -427.24. ಅಲ್ಲ, ಸರಿಯಾಗಿ ಕಾಣ್ತಾ ಇಲ್ಲ, ಬೆಳಕಿಲ್ಲ. 427.56 ಕಿಲೋ ನ್ಯೂಟನ್ ಮೀಟರ್. ಸೇಮ್ ಆನ್ಸರ್ ನೋಡಿ, ಸೇಮ್ ಆನ್ಸರ್ ಬಂತು. ಆಯ್ತು. 24 24 ಬಂದು ಸರಿಯಾಗಿ ಕಾಣ್ತಾ ಇಲ್ಲ, ಬೆಳಕು. ನಾನು ಅಲ್ಲಿ ನೋಡ್ತೀನಿ ಇರಿ, ಇನ್ನೊಂದು ಮಾಡ್ತೀನಿ. -427.24. ಕರೆಕ್ಟ್, ಇಲ್ಲ ನೋಡಿ, ಕರೆಕ್ಟ್, ನಾನು ಇಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀನಿ. ಆಯ್ತು. ಈಗ ಎವ್ರಿವೇರ್ ಓವರ್, ಲಾಸ್ಟ್ಲಿ ಗೋ ಫಾರ್ ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್ ಡಯಾಗ್ರಾಮ್ ನೋಡಿ. ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್ ಡಯಾಗ್ರಾಮ್, ಸ್ಯಾಗಿಂಗ್ ಪಾಸಿಟಿವ್, ಆಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಆರ್ kn meter. BM at C. Before that one, variation you have to write. 1 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 + 4 + 2 Between these 2 points, no shear force variation or no shear force, no load, nothing, right? Bm is constant. C to D, parabola of second degree. D to E, parabola of once again second degree. E to B, parabola of third degree. Aitu. ಈಗ plot here 143.56 ನೆಗೆಟಿವ್. ಓ ಇಲ್ಲಿ ಎಷ್ಟು ಅಲ್ಲ 140 ಅಲ್ಲ, ಎಷ್ಟಿದು 427.24. ಹಿಯರ್ 143.56, 14 ಅರೌಂಡ್ 1/3. ಹಿಂಗೆ ಹಿಂಗೆ ಸ್ವಲ್ಪ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್. ಇಲ್ಲಿ ಎಷ್ಟಿದು 100 ನೋಡಿ 43.56. ಓ ಇಲ್ಲಿ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಇಲ್ಲಿ ನೋಡಿ, ಈ ಪಾಯಿಂಟಲ್ಲಿ ತುಂಬ ಕಮ್ಮಿ 37.64. ಅಯ್ಯೋ ಬರೆಯೋಕ್ಕಾಗ್ತಾ ಇಲ್ಲ, 30 ಓ ಇಷ್ಟೇ ನೋಡಿ, ಇಷ್ಟೇ 37.64. ಓ ಹಿಯರ್ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಓನ್ಲಿ -20. ಹಿಯರ್ ಆಲ್ಸೋ -20 ನೋಡಿ. ಕಾನ್ಸ್ಟೆಂಟ್ ಹಿಯರ್, ಪ್ಯಾರಾಬೋಲಾ ಆಫ್ ಸೆಕೆಂಡ್ ಡಿಗ್ರಿ ಈ ಥರ. ಅಯ್ಯೋ ಕರು ಸರಿ ಬಂದಿಲ್ಲ, ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಬೇಕು ನೋಡಿ. ಕರೆಕ್ಟ್. ಸಿ ಆಸ್ ಯು ಗೋ ದಿಸ್ ವೇ, ಶಿಯರ್ ಫೋರ್ಸ್ ಇನ್ಕ್ರೀಸಸ್, ಸ್ಲೋಪ್ ಇನ್ಕ್ರೀಸಸ್. ಹಿಯರ್ ಶಿಯರ್ ಫೋರ್ಸ್ 0, ನೋ ಸ್ಲೋಪ್. ಫ್ರಮ್ ಹಿಯರ್ ಟು ಹಿಯರ್, ಪ್ಯಾರಾಬೋಲಾ ಆಫ್ ಒನ್ಸ್ ಅಗೈನ್ ವಾಟ್ ಸೆಕೆಂಡ್ ಡಿಗ್ರಿ, ಸ್ಲೋಪ್ ವಿಲ್ ಬಿ ಮೋರ್, ಇಟ್ ವಿಲ್ ಬಿ ಮೋರ್ ಸ್ಟೀಫರ್ ನೋಡಿ. ಸ್ವಲ್ಪ ಫ್ಲಾಟ್ ಆಗಿರಬೇಕು, ಲಿಟ್ಲ್ ಫ್ಲಾಟ್ ಹಿಯರ್, little flat. This is steep. Okay. From here to here, shear force is furthermore. And one more thing, see here. Here, this side and that side, both side shear force constant. Therefore, tell what? This is second degree. This also second degree. This is third degree curve. And this, if I draw tangent here and tangent there, both of them should have common tangent. Why? Tell me. Because shear force this side is 139.6, shear force that side is also same. So slope of the tangent should be common. It should be a common tangent, second degree and third degree. I should not explain furthermore because these all told so many times earlier. Nodi illi shear force increases, slope increases. Shear force increases, and this side more shear force, little steep, and here furthermore shear force steep, and here either side shear force same. Therefore tangent should have common tan theta, and here high shear force very very steep. Here the tangent to this slope will be 166.6. Now full clear? Those who are serious and going through every class and understanding every concept, tell me, full clear or not? My purpose is to make clear only for those who are what? Serious and hardworking and dedicated. People who come once in a while for time pass, I have no time for them. Full clear? Beg everybody. And is correct agi? Full clear or not? Clear. Okay. Now, if anybody finding difficulty, if all these things are doubts are there, that is possible. If you join late, you start from class number 1. Instead of wasting time elsewhere for unwanted things or useless things, start from class number 1. Go through every class thoroughly. See, reach today's class. See where you stand. In SFD&BMD, you see where you stand. You will reach such a confidence that you will tell, SFD&BMD, I am the champion in the world, not me. You will tell, you should tell throughout the world, I am the topmost knowledge holder in SFD&BMD. And not me telling, you should tell. Nobody can challenge me in SFD&BMD. Plus, please don't tell me in front of me. That's all. ನನ್ನ ಮುಂದೆ ಹೇಳ್ಬೇಡಿ, ಮಾತ್ರ ಕಷ್ಟ ಆಗುತ್ತೆ ನಿಮಗೆ. ಟೆಲ್ ದಟ್ ಇನ್ ದ ಕಮೆಂಟ್ ಬಾಕ್ಸ್. ಯು ರೈಟ್ ಐ ಆಮ್ ದ ರಿಯಲ್ ನಂಬರ್ 1 ಇನ್ SFD&BMD ಅಂತ ಡೋಂಟ್ ರೈಟ್ ಇನ್ ಕಮೆಂಟ್ ಬಾಕ್ಸ್. Okay. Otherwise, everywhere you can tell, provided you show dedication. Okay. Now, today's class question, fully clear? I will take one more cantilever, then I will change the chapter. Because, and then remaining questions will continue in the course, not in your course. I will keep on uploading one by one, starting from 1 point load, eccentric point load, UDL, couple, full. Maybe when you finish it, when I finish the cantilever, it will reach class number 180. 170, 180, because 20 classes I require for that special problems. Drawing BMD from SFD, some timber beam floating in water, and then sometimes bracket problems and conditional problem. I need some time. Okay, thank you. Tomorrow I will cover more questions on cantilever. I will do one thing. I will put some couples in between. Then there will be a sudden change of bending moment. That I will cover tomorrow. And I may put one trapezoidal loading tomorrow. Okay. UVL represented by trapezium. So tomorrow we will close this cantilever. Okay, thank you. We will close cantilever for BSK. Not our course is going to close. Course will continue for another, at least another 100 more classes, nearing 100. I will see that it will touch 200. Not for making it 200. I got enough what? Matter or enough material or enough what you can call is cases to reach there. Okay, thank you.